Hello. It's 7, so I'll go ahead and start. Um, Today I'll be covering AP Computer Science principles. I know on the sheet it said biology. That's my fault. I got that mixed up. So, I hope you still find this one interesting if you came for biology. So instead of doing computer science next week and bio this week, I'll be doing bio next week and computer science this week. Okay. So, we'll start off with a review of what we talked about in the first presentations. So it's just what's in the computer science exam. So this exam has two parts. It has a create performance task and a multiple choice part. So the create performance task is a code-based project that requires all these things, along with a written portion, a video, and a copy of all the code. It's worth 30% of the final grade. So I'll be going over this more in detail later in the presentation, but then there's also the second part of the exam, which is the multiple choice. It's 70 questions with 120 minutes to complete, and it's worth 70% of your final grade. At the end, I'll go over a couple of the multiple choice questions that you might encounter on the test. And yeah, so next. So today we'll be going through a summary of all the content in computer science course, along with a deep dive into the create performance task, and as I said, a couple of multiple choice questions at the very end. So starting with the summary of the computer science course. So this course is split into 5 big ideas or categories. Categories or big ideas. So the first one is creative development, then data, then algorithms and programming, computer systems and networks, and finally the impact of computing. So the first one is creative development. So this section of the exam, or the section of the content, is split into 4 subunits: collaboration, program function and purpose, program design and development, and identifying and correcting errors. So in the first topic, collaboration, what you'll learn is that computing, or going into this computer science field, there's a very small percent chance that you'll be working by yourself, because in computing, when you're creating a program or a software or something, you want it to be able to apply to a whole lot of people, almost everybody. But if you yourself are the only person that's making it, then you'll probably have some underlying biases that you might have that you might not think of. That's why collaborating is good. It'll help you eliminate these biases and get more ideas and help for your program or something. So that's basically what collaboration is all about. Then there's program function and purpose. So the function of a program is literally what the program does, while the purpose is what it's meant to do, or why you made the program in the first place. So then there's program design and development, which is basically, as the name sounds, you design and develop certain programs. So learning in this section, you will learn how to create programs and how you should design something to solve a certain problem. And then finally, the identifying and correcting errors, which is basically just troubleshooting. So on the test, on the exam, the multiple choice portion, there will be a lot of troubleshooting work that is a big portion of the exam. So this first creative development portion is really just an overview of very key elements of what you'll need to know for the computer science exam. So the next portion is data. So as time is progressing on, we're getting more and more data into our systems. So data is just information. In this case, we're talking about computer data, so information for computers. So the first topic is binary numbers. So in this, I think most of you will know, but binary numbers are just ones and zeros. So like how humans work on a system of 1 to 10, computers work in binary, only with zeros and ones. So on the exam, you may see stuff like converting between binary and decimal. There's also something hexadecimal, which is base 16, but there won't be any sort of deep dive into that. It might show up on the test, but you won't need to actually know how it works or how to convert between binary or decimal to hexadecimal. A cool fact is the power button that looks like kind of like that is actually a 0 and a 1 to represent binary numbers and what computers operate on, which I thought was pretty cool. But anyways, then there's data compression. So data compression is basically making a big data into a small data file. So this is because for example, if you're trying to transfer some files over from one computer to the next one, it is a lot easier and faster to transfer a small file than a big file. So this is where data compression comes into play. So for example, if you had 100 kilobytes of something, you could make it into like 4 kilobytes of something, and then it'll transfer faster compared to that big file you had before. So you won't have to know any of the details in data compression. You just have to know that it exists. Also, there's there's two types of files. There's lossless and lossy files. So basically, you learn that lossy files are files like JPEGs that, for example, I have a good quality image and I send it in a JPEG format to my friend. When they receive it and download it, the quality will be significantly, or not significantly, but usually it'll be lower than what it started with. Then there's lossless, which means if you send over a file, it will be in the same quality and it won't lose any sort of quality. Then there's extracting information from data. So like I said before, the data in our world right now is growing more and more, so that we have to process through these data to find the important portions of information that we need. Because of course you have a lot of random data that you don't actually need for your specific information that you're looking for. Many computer science jobs include stuff like data analysis, which is basically extracting information from data. So then there's using programs. So this is linked very much with the previous one, which is extracting information. So there are many programs you can use to extract information from this data, and that's, for example, a very, very simple example is like if Control F was a program, you're trying to find some specific sort of data or some specific thing in a PDF or something, you can use Control F, which is like a program, to find what you're looking for and extract the information you're looking for. Okay, the next one is algorithms and programming. So this is the bulk of what you're going to be learning. It's all the basics of the coding stuff, basically. So the first 3.1 is variables and assignments. So that top left picture is just assigning a certain expression to variable A. So that's what your code will look like on the exam. So I'll just say that the exam code, the code that is used on the CSP exam, is not any specific language. So it's not specifically block coding, which is what's shown on the right picture with the black background. And it's also not like anything like Python or Java. It's more of a mix of Python and block coding, and but they're all like certain quirks and stuff. Your teacher should go over this in their explanation. It's also given to you on the College Board website, which you can look at. But anyways, so then 3.2 is data abstraction. So abstraction is used a lot in this course. So basically it's putting a more complex thing into a simpler format, kind of. So with here, give me a second. So here you can see this is a code that I did for class. So there's this, it's kind of hard to see, but there's this this function called draw half circle. So it has all this this code inside of it. So this is a data abstraction. So I put all this code under draw half circle so that when I use draw half circle, I won't have to write in all of this code. And then this draw half circle is used in many other places that I wrote. For example, this draw J function, which uses draw half circle, it keeps me from having to rewrite this entire code right here, down here. And then there's also another one where I use it again. So basically, abstraction is just to make your code a little bit easier to look at and also make it easier to troubleshoot later. For example, if I have a problem in both of these, then I might know I should go check my draw half circle function instead of having to go through all of this. It also makes your code look a lot cleaner and makes it easier to work with. Okay, next is mathematical expressions. This is pretty simple. It's just like plus, minus, dividing, square roots, exponents, stuff like that that you'll learn during your coding. Then there's strings, which are basically any sort of word format or sentence structure that you want to do. They'll be in the form of strings. Okay, then there's Boolean expressions. So bools are anything that result in a true or false. So for example, I say apple equals, or apple is equivalent to red. So if that's true, so if my apple is red, then it'll evaluate to true. But if my apple's green, that will evaluate to false. So using these bools, they come into play in conditionals. For example, on here, there's if condition, and then it gives you some sort of command. So the bools play in so that if this bool evaluates to true, then this command will happen. So any if statements are conditionals. Then there's nested conditionals, which basically means it's an if inside an if. For example, if I say, if Bob is above 5 feet, he can go on this ride. But if he's not 5 feet, if he's not 5 feet, then if he is under 4 feet, then he can go on this other ride. So that's just an if statement inside another one. Then there's iteration. This comes up. This is very important in the create performance task. So iteration is basically a loop. So any sort of repeat function or while function, which I'll go into detail later. Then there's developing algorithms, which is pretty simplistic. It's just developing algorithms and function and code. The next one is lists, which is also a very big part of the create performance task. So a list is like a special variable that can hold different variables under it in a list format. So in some specific sort of order. They're very important and can help you save a lot of like variables if you're making a lot. Then there's binary search. This doesn't come up that often, but I think all you need to know is that it's a type of sorting algorithm kind of thing, where that all of your numbers have to be ordered from smallest to largest, or it's like if it's letters alphabetically. Then there's calling procedures. So for example, back to my draw half circle function, for a procedure call, it's just when I use this function, that's what calling this draw half circle procedure is. So this is a call to the procedure. Developing procedures, same as developing algorithms, pretty similar. So libraries are the next one, which are basically, it's like a library of all these functions that you can use and import. You can import them into your system so that you can use all these things that come with it. For example, in Python, there's an import math function in which you can use all these special math functions like square root or anything like that. The random values are just random values, just randomly generating numbers. Simulations are just real world things, but on a smaller scale usually. So if you can't do something in the real world, you'll use a simulation to mimic it and see results. Algorithmic efficiency is how fast or how efficient this algorithm will be in calculating something. And then undecidable problems are basically just problems that a machine can't compute. Okay, now to the next part, which is computer systems and networks. So the internet section of this is very, I think, vocabulary heavy. If anything about the internet shows up on the exam, it's usually some sort of vocabulary asking how something works, or asking how this transfers over, or how two things interact in the internet. So knowing your vocabulary for this is very important. Then there's the second one is fault tolerance. I have a picture in the bottom right. So basically, fault tolerance is what it sounds like. Computers have fault tolerance to keep them from if one thing fails, from everything messing up. So this bottom picture shows it pretty clearly. So if I'm trying to transfer from this computer to this place, I have multiple routes to go through to keep me from, for example, if this line broke down, if this blue part broke down, there wouldn't be a problem for this to go and transfer. Multiple of these different blue things would have to mess up to have nothing work, to have this file not be able to transfer over, which is what fault tolerance is. Then there's parallel and distributed computing, which is just how computing works. For example, in parallel computing, two things can happen at the same time on one device, while distributed computing is you have one task split over multiple devices. Okay, on to the next one. So impact of computing. So computing is a relatively new sort of technology. So there are lots of studies on like the beneficial and harmful effects, the digital divide, which is basically the growing divide between people who have internet and computing stuff and people who don't have it. And then there's also computing bias, crowdsourcing, and then legal and ethical concerns are very important. They're a pretty big topic on like what data is safe, which plays into the next one, which is safe computing, but which data is safe to be able to use on like when big companies are trying to get logistics or statistics on something. Yeah. So now moving on to the create performance task. So like I said, this is 1/2. It's actually like more like a third, but it's like a half of your whole exam. It takes up the free response portion, so which is pretty good in my opinion. Okay, so the create performance task, you have the entire school year to finish. So unlike the multiple choice exam where you have to go to school and then finish it in school and have a certain time limit, for the create performance task, you have the entire school year to finish. So as you can turn it in anytime between, anytime before the due date, which is usually, this is kind of confusing, but on the day of your exam. So for example, this year, the day of our exam was May 17th. So as long as you turned in your create performance task before May 17th, it was okay. So you have the entire school year to finish this. It can be in any language. Your code can be in any language. So the popular languages are Python or block coding. And then, so the code has to include an input. So the code has to include an input and output, a list or array, and then a student developed procedure that has a parameter that includes sequencing, selection, and iteration. So on the right here are a bunch of pictures of these things that we'll need. So for example, here is an input thing. So in Python, if you want to create input, you have to write the word input. And in the end, this blue text is what it'll look like once the computer processes it. So once it shows out, it'll be like, enter your first number. And then here it gives you a place to type something. This is an example of block coding. So I used Snap, which is at snap.berkeley.edu. You can also use any other type of block coding, but it has an ask function where once you ask something, once it shows up on the interface, it'll look like this, and it'll have somewhere to type your answers. So input generally is just anything you give to the computer, and then the output is anything the computer gives back. So any sort of input like buttons or like text, which is what I've been using, or like clicking something, those are all forms of input. Output is just, like I said, the result. Also, what's required is a list or an array. So like down here, I use results list as a list that I used. It's just something you have to have, or else you won't get your points. There's also a student developed procedure. This is the procedure for one of the practices we did during class. So a parameter is just something you input into the calculator or into your function. So this thing right here, that's a parameter. So if it was just calculator, it wouldn't have any of these x's, and that wouldn't be a function that would work with the create performance task. So sequencing, selection, and iteration are three big things that you need in your function. So sequencing is the order of something. So on here, there's like print this, then print this. That's sequencing. Is just one thing after another. Selection is any if statements, or else statements, things that require you to have some sort of selection. And then iteration is just any loops. So in Blockly, you usually have like forever loops or repeat how many times loops. In Python, they're like while loops or for loops, but that counts as iteration. So moving on. So here's an example that I did during class. It's basically, I don't know how clear this is, but it's basically a program where it wrote my name. Here's the code on the side up with big. So this is just strictly sequencing because there's no sort of if loops or if statements or like loops. So this is just do this, do this, do this in a specific order, which is what sequencing is. Then there's selection. So selection is any, like I said, any if statements. So let's see, it's a little bit small, but I did this magic 8-ball thingy for a class project. So basically, it's where you, it's just you import something random, and nobody really, the code doesn't care what you import. What you input into the thing. It's just it just chooses a random word to give back, and then yeah, that's basically what this project did. Okay, and then that's just an if loop. And then finally iteration, which is loops. So in this project, I'm gonna try not to zoom in, but it's basically, it drew a bunch of triangles. So in this iteration is just repeats. So here you can see a lot of repeats. So any of these repeats will be fine for your iteration. Okay, so the create performance task, besides just the coding part, you also have a written part. So it's limited to 550 words, which if you know, if you write big papers or something, that's not very much. It's a pretty short thing that I think you can do in less than a day, maybe 2 if you want to spread out your work. So it has 4 big parts, so A, B, C, and D. It has something to do with how it's graded. There's no reason why it's split that way. And then each big part has multiple individual like questions. You also have code snips, which are just screenshots of any specific code that they want to see. And then there's special action words in this create performance task written part, which is identify, which is provide a name for the specific topic without elaboration or explanation. This is usually like a 1-word or 2-word answer. There's no need for you to write anything extra because it's not going to be graded. Then there's describe, which is providing relevant features or characteristics of what the program code represents or is being used to accomplish. So it's just describing your code. It's longer than your identify, but usually shorter than the explain, which is providing information about how or why a relationship, situation, or outcome occurs, listing detailed steps of the algorithm or using evidence and or reasoning. So explain is the longest thing. You usually have to write a lot for it, but yeah. So then there's your video. So your video has to demonstrate your program running. So it has to have your input and at least one aspect of the functionality. It just means sometimes when you have you wrote your code so that it could have 2 different paths, so like an if path or an else path. So just one of those would be fine for your video, and then it has to also show your output, so what your program gave back. So to keep this the create performance task fair and unbiased from judges, you're not allowed to put any sort of information about yourself in this video or in the in your code. But for example, you can't have your voice because they might be able to tell if you're male or female, and then you can't have any other like pictures of yourself either. Then there's some formatting things, so that'll come up into play once you start making it. But usually videos are like less than 30 seconds long, I think, so it shouldn't be a problem to get it in those formats. Okay, next is example of a create performance task. These are just code snips. So I'll give another example of this later for like the entire thing, but B1 and B2 are the first places where code snips are required. So for example, it says B1 must show how data have been stored in the list. So here is my B1 code snip. So if you have any sort of not editing, but like picture editing software on your computer, you can like highlight out where this specific thing is just to make it easier, clearer to your reader or your grader to know where your answer is. Then for B2, I did this, so it's just the same list. It's using the same list, such as creating new data, blah, blah, blah. It's just using the list to do stuff. So so for B1, I use results list. So for B2, I also have to use results list, and this is how I did stuff with it. Then there's C1, which is basically your entire student developed procedure. Here's mine, and then here is where it's being called. So we discussed, I just described this earlier, but calling your procedure is just where it's being used. So my procedure trans sequence was being used at the very end where it translated this thing called DNA raw. So here's a different example that I'll be going over. I'll just go over the entire create performance task for this. Let me see if I can make this. So basically for this, it's like a super big calculator, a polynomial calculator, where you inputted a bunch of variables and then how many times you wanted to do something, and then that's how many times it would repeat, and then it would compile all of your answers at the very end into a list, and then it would print that out. So here's just me entering random numbers, but it's theoretically useful if you were wanting to use it in math, and then there are the results at the end. So that would be an example of a good create performance task, because it shows your input and your output and all those things that you need. Anyways, next. So keeping that in mind, we start with describing the overall purpose of the program. So I said the purpose of this was to calculate as many polynomial problems as the user wants, and then print the results all together in a list. So I also gave a place to like theoretically use it in real life. And then there's functionality. So I mentioned earlier that purpose is what your project is meant to do, or what it's supposed to do, and then the functionality is what it really does. So it says the program is demonstrated in the video specifically, so you need to apply what you recorded in your video to this written response. For example, I inputted like 2 for how many times that I needed my program to run. So, and then that's exactly what happened. And then for A3 is describing input and output of the program demonstrated in the video. So our teacher told us to write in a timestamp just to make it easier on your reader or your grader, so they know that where you're getting your information, or where just so like the input is very clear. Your teacher might tell you to do it differently, which is just also fine, as long as it's clear enough for your reader to understand. Then the second part, I went over an earlier example of how B1 and B2. But so the first program segment should show how data have been stored in the list. So here it's like results list dot append. This means you're adding results to a list. Then there's print. Then there's a print element, which is just the second program screenshot. Somebody asked this earlier. I'm sorry, I didn't see this. Yes, there should be a recording. Is it recording? Sorry, I think it should be recording. But somebody else asked if I mind. Somebody else asked if when I started to code. So I started coding back in elementary school, like when I was, it was mostly for fun, and it wasn't really serious coding. So it was like on like Scratch. It was very block coding. I didn't do any sort of typing coding. But what age was, so I think coding is really fun for elementary schoolers, even if you're not really learning any of it. It's still like fun and interactive and pretty educational, I would say. I did a couple serious coding things back in middle school when I started learning like Python and stuff, but it's not required to know any sort of coding before you come into this class, because your teacher should teach it all. But I suggest kids to start learning coding. You can introduce them at like a younger age in elementary school, and just they can have fun on it and play games and stuff, which is a good incentive. This video should be posted on YouTube. I'll see if I can get it there soon. And then somebody asked if we need to be really good at coding for this. So I don't think so, because this course is called Computer Science Principles. Basically means that everything in here is fundamentals of like the computer science world, but also in some basics of coding. You don't really need to be good at it, but I think knowing some basics or being good at coding would be very helpful, and it makes your life a lot easier. For example, I started this course with a good knowledge of how to code, so which made the computer science thing like it just made the class a lot easier. Yes, if you email me, I will send you a link. It should also be in the WeChat thingy if you're in that. Okay, moving on. So this part is also, I showed you before, but you have your results list, and then your other list. I mean the same list, in a where it's being called, and then finally they just want you to clarify what list it is in case there are multiple lists in there. I'll drop my email in the chat at the very end in case you want it, to anybody who wants it. I'll do it at the very end. So then there's more parts where it's basically, So here's the first describe one. So you can read it yourself, but it just wants you to tell you what it just wants you to tell them what is in your list. And then here B5 from what I heard is one of the harder one to get points on. So you have to explain how your list manages complexity. So basically how, like, why your program code could not be written without it, or how it would be written differently if you didn't have the list. You could do either or. So like you could do either this one or this one, but our teacher suggested that you can just write both, and because then if one is wrong, you can usually get points for the other. So like a safety net. Next is asking for your program code segment. So like for this one, you have an if path and an else path, and then the print. So parameter again is this X thingy. Yeah, sequencing, selection, iteration. Then there's where it's used. So here I highlighted it out. Again, if you can do some sort of highlighting thing, it'll be very helpful to your reader who might have trouble finding it. And then C3 is describing in general what the identified program does and how it contributes to the overall functionality of the program. So here, as you see, I use bullet points for this. So on your written response, you can use either bullet points or full sentences. Because there is a word limit of 550, sometimes bullet points are more easy to use. But yeah, it conserves on word limit. Similar to any sort of free response thing, it's fine to keep your stuff very concise, because it makes it, if you don't have any like flowy or big words, it's very direct and to the point, and your grader isn't looking for any sort of big words or any sort of English. They're not grading you on English, they're grading you on your content. So it'll take more time to do that. So just saving your time and saving your effort, also saving words if you do everything more concisely. Okay, and then finally, it wants you to explain how the algorithm, just so that in case like it says that it must be detailed enough for somebody else to recreate it just by reading your thing. Yeah, that's pretty self-explanatory. Also, something I forgot to mention before, I think, but you can collaborate on your code. So like, for example, if you're doing your create performance task, you can collaborate with somebody else, like your friend who's also taking the course. You can make your code together, or you can get somebody else, a friend or something, to check over your code for all of your stuff. So you can do that together, but when you're making your written response, it has to be done alone. If College Board gets any wind of you having done it with somebody else, or having the same exact written response as somebody else, they'll probably cancel your score, and also you might have some bad repercussions. Okay, anyways, D1 was describing two calls. So this D portion is mostly it's just like what would happen if you, calls are just like how a different like using a different variable in your thing. So for example, for here I said if you put 0 in there, it would go to the if path, and if you did poly procedure with 5, it would go to a different path. And this is a little bit more in depth of coding, which you should learn in the class, but yeah. And then the final one is like, so it was your calls, and then the conditions, what it's testing for, and then the result. Okay, so finally we're to the multiple choice. So in the multiple choice, there are many different formats of questions you'll see. So for example, there'll be ones like this. Not like this, but this is just an overview of how computer science, the code works. I mentioned this earlier, but it's not a particular language. So it's like a mix of Python and block coding. So for example, here's an example of what it might look like. So there's I used this picture earlier, but it might look like this or like this. It just depends on how the people want to use it. These both mean the same thing though. You'll get more into the syntax of this when you get into the course. But anyways, there might be questions like this where it gives you this is in Word format, but stuff like this. If you see these questions, they'll be like, and then it'll ask if something changed. For example, a lot of these questions appear in a format that like they'll be like, oh, this thing doesn't work. So now choose one to fix it. Choose a question, choose an answer to fix it. So for example, it's asking that which change would make it so that it would work. So this requires you to know how this code needs to function. So you need to know what needs to be changed to get the correct result. Then there's stuff like this, which is basically vocabulary. Just for these questions, you're just gonna have to study. So for the previous types of questions, mostly as long as you know the code and you can do it fairly quickly, it'll be fine. But for these, if you don't know your vocabulary, there's a very low chance that you're gonna be able to get this question. But I mean, you could guess and probably get it right. Then there's things like this where it gives you some sort of diagram. So this is what a very typical Boolean, so true or false. So like this happens and then it either evaluates true or false, and then other stuff happens. And then it's saying like which is the least likely to be included. So, and then it gives you a bunch of things for you to choose from. And then there are questions like this. So computer science and I'm pretty sure the other two are AP Physics 1 and 2. But anyways, computer science principles has a section at the very end. It's part of the multiple choice, so in the same testing section, but it requires you to choose two different answers. So see how it says select two answers? So it's asking which ones would produce the same result as this. So you have to choose both answers as the right answers, or else you have to choose both of the correct answers, or else you won't get points at all. So that's very typical. There, like I'm pretty sure it's 8 questions at the very end of the test, where you have to choose both answers. It'll be very clear which ones they are. So just make sure you know that. Oh, I was also gonna say the computer science exam is a fairly long exam time-wise. You have like 120 minutes to do 70 questions. So you have more than enough time to finish out all of your questions. For me, I also had like a bit of time afterwards, so you always have time to check your answers. Yeah. That's the end of my presentation. This one was fairly short compared to all the others. If you have any questions, feel free to drop them in the chat. If not, you can go ahead and go, I think, because this, like I said, this presentation was fairly short. Let me go back up to the So yeah, you have 70 questions with 120 minutes. Oh yeah, I said I dropped my email, sorry. There you go. Wait. You can email me if you want a copy of these slides. Try to use it for personal use though. I don't want these to be distributed out. I can also send you a link to the video once it's done. Yeah, you can get a copy. I'm pretty sure it will be going in the WeChat thingy, but if you want a copy of it from like YouTube, I can send it through my email. Just email me for it. But yeah, you have more than enough time on the multiple choice part if you would. So you don't really need to worry about this. I found CSP to be a pretty easy class in general, but the exam pass rate is kind of low for 5. No, the pass rate is very high, so that's just getting a 3 or higher. But the generally getting a 5 on the exam is pretty hard because you can only miss so many questions. Yeah, I can send previous recording as well. Just email me and yeah. I think that's all. Let's see. If you have any questions, feel free to drop them in the chat, or you can go if you would like. Thanks for attending though. I hope this was interesting and or like at least like useful for people who are going into computer science or are thinking about. So somebody asked if we need to learn coding in middle school to take this in high school. Short answer, no. You learn all the coding that you need in this class, but it is helpful to like already know certain content. So it might be good to like just do like a short online course of introduction to like something like an easy language like Python, or you could just play around with block coding. Anything would work. But yeah, you don't have to know coding, but I think coding is fairly fun in general, so you can just do some on your own time. So let's see, I'll stop sharing now. Thanks for attending, y'all. I'll stop recording too.